Before we start condensing expressions to a single logarithm, we need to remember or review a rule of exponents. So for example, if you have something, a number that is, say, the fourth root of a to the third power, right? This is a rule that we need to go backwards. And so think about before, we talked about rules that look like this, where your exponent that is attached to the base comes from the numerator of a single fraction, and this nth root is your index. And so usually we look at this as the nth root of something to a power. And so that's what we're going to do, is we're going to turn this number backwards into these types of formats. So if you have a number that's written like this, you can rewrite that as a to the 3/4 power. Right? Likewise, you want to be able to go from the right to the left. So think about a logarithm that might have the 2/3 log base 4 of x. Right? So thinking about the rules that we talked about previously, this number out front, this factor, is really the exponent on that base. And so what we're going to do is our first step is going to be to put that power on that base and then move backwards to something like this. So again, the numerator is going to stay attached to the base, and this denominator is going to be our root. And so that's going to give us log base 4 of the cubed root of x squared. And so when you're condensing down to single logarithms, you're going to need to start and go through this process of take a number on the outside and create it as the exponent. And then if you have a fractional exponent, you're going to need to write it as an nth root. So let's look at a few others, how we can condense using other rules at the same time. So how about we do 3 log base b of x plus 1. Right? And then I'm going to do a minus 4 log base b of x. And then I'm going to add to that a 1/2 log base b of, let's just say, y. So my first step really needs to be putting any of these numbers out front as a power. And so that's going to keep my log base b of this x plus 1 to the third power minus log base b of x to the fourth power plus log base b of y to the 1/2. Now with this negative one, I could have put the entire negative 4 attached to the x, and I'll do that later on another example where I'll show you how you could do that. But since we did this yesterday with another negative, I'm going to show you that concept. So any of these terms that have a positive in front are going to stay in a numerator. Any terms with the negative are going to be in the denominator. So as a single logarithm, I'm going to only write log base b once, but I'm going to create a fraction where this x plus 3 cubed is in the numerator. The other positive is the y to the 1/2 power, but I don't want to write that as the 1/2 power. I want to write that as the square root of y. And then in the denominator, because there's a subtraction sign, I'm going to put that factor down in the bottom. And so this is what our condensing looks like as a single logarithm. Right? And I know it's kind of tight here, and this looks like that's supposed to be the cubed root. So we need to try to make sure that we don't squish it this tight. I was trying to skip a step. So let's try to make sure we expand that or spread that out just a little bit further. But you can see any of the terms that had a negative in front are going to go in the denominator, just like yesterday when we expanded, a denominator got written up this way. So you think about if I could move my way backwards, then I did it pretty well. Okay. So let's look at one more. Again, let's do something where they all have the same index, like a 1/4 log of x minus 1 plus a 3/4 log of, I don't know, x plus 3. And then let's do a minus 1/4 log of x plus 9. Okay. Now, when you have logarithms where the number in front is fractional and they all have the same denominator, this is going to be something where each of these terms are going to be underneath the same root. So let's start first with our same process as we did last one. So this log of x minus 1 is going to be to the 1/4 power, plus the log of x plus 3 to the 3/4 power, minus log of x plus 9 to the 1/4 power. All right, and so since they all have an index of 4, we really need to think about how exponents work with quotients. And so just to remind you that if I had a square root of a number, right, that each one of these can have the same power. Right? It's kind of like a rule of exponents and radicals, is that each numerator and denominator gets the same radical, and then if I turn those radicals into powers, they would both have the same power. That's the same kind of thing here, is they're all going to have a denominator of 4. So when I do this and I convert this into one logarithm, again, it's going to be a quotient, right? But the whole thing is going to be raised to the 1/4 power. And the numerator number is going to be the exponent that goes and attaches to each one of these bases, just like it does up here. So when you have a numerator number, that's what attached to the base underneath. So we're going to do the same thing here. Right? So I'm going to leave my x minus 1 and my x plus 3 in the numerator. And I'm going to, oops, let me give myself more space. Let's redo that. It's a little not enough room. And that can happen sometimes, which is why you have to use pencil. So x minus 1 times the x plus 3 to the 3rd power. So again, I need to keep the numerator attached to that factor. And then in the denominator, I'm going to have my x plus 9. And so each of these that have just a 1 in the numerator is going to leave me a 1 here. And then I'm going to leave my 1/4 power. And again, I can't leave it that way. So what I'm going to do is I'm going to write this as the log of the 4th root. And underneath I have my x minus 1 times x plus 3 cubed over my x plus 9. And that will be how my final root needs to be written. So again, you need to make sure that you put the 1/4 power on the outside. Now, some other things that we need to do is we want to be able to approximate a logarithm. And we're going to approximate a logarithm without a calculator. So it's called to 4 significant digits. So what we've done is we've taken a value and we've approximated it. And so now we're going to use that approximation. And so here's the information you're going to be given. Log base A of 2 is approximately 0.3562. Log base A of 3 is approximately 0.5646. And then also log base A of 5 is approximately 0.8271. So each of these logarithms, where there's a factor of 2, 3, or 5, have their own 4-digit approximation. And you're going to be using the rules to simplify this and try to approximate a different logarithm. For example, if I have the log base A of 15. All right. Well, to do that, I need to split up 15 using the rules of exponents. And that's the same thing as log base A of 3 times 5. So I see my different factors, and when I have different factors being multiplied, that means then I can split this up as 2 separate logarithms with addition. And now what I'm going to do is, now that I have it separated as specific logs, I'm going to use those values with this sign. So this would be this approximately the 0.5646 plus the value I had for the log base a of 5, and then I can do that in my calculator. Right? So altogether, we can approximate this. Right? So 7, 1, 9, was it 13? All right, so if this is the value that we get, all right, oops, I think I put my number in the wrong spot. Forgot my decimal in the wrong spot. All right. So this is your approximation. So you're going to split up your logarithm of the number you see using different rules and see factors, and then use the approximation in the order of operations that you're given. All right, so let's try another one. For example, log base a of the cubed root of, say, 18. So using our rules, all right, this is the same thing as log base a of 18 to the 1/3 power. And I need to simplify this down and think of how can I break up 18. Well, that's the same thing as 2 times 3 squared. And so you're going to have to really think about prime factorization and how you can write 18 into smaller bases using powers. All right. Then I can put my 1/3 out front and write this as log base a of 2 times 3 squared. Oh, okay. I needed to actually deal with that as well. So let me redo this. I messed up my exponents. So we did this yesterday and we had our exponents. I'm going to put my log base a, and I'm going to give my 2 the 1/3 power. And then I'm also going to give my factor of 3 that 1/3 power. And so this will be easier to split up this way. And so we talked about that a little yesterday, that you needed to attach the power to both, and this is why, is that was going to start getting a little bit nasty. All right? And so when we do it now, I'm going to split this multiplication up and do the power at the same time. So I have a 1/3 log base a of 2, and then I'm going to add a 2/3 log base a of 3. And so what I've done is to try to shortcut this a little bit. I've separated out my multiplication of 2 separate factors into the first property that allows me to create that as addition. And then I've also brought my power of each one out in front of their own logarithm. And so now I'm going to need to have 1/3 of the value that was 2.3562. And then to that, I'm going to have to add 2/3 of what log base a of 3 is to 4 significant digits. And that is what we're going to need to put in our calculator. All right, so let's try that. So I'm going to do 1 divided by 3. I'm going to make that times 0.3562. I'm going to add 2 divided by 3 times 0.5646. And I get that this is approximately 0.4951 if I keep this to 4 significant digits. Okay. So this is going to be your process with condensing logarithms and also approximating to 4 significant digits. You will need to use the rules of expansion, and then whenever you have a log of a certain base where you have been given the 4 significant digits ahead of time, those are what you're going to substitute. But everything is going to be order of operations when you do this.